Hello everyone, welcome to AI Anytime channel. In this video, we are going to see how we can quantize a large language model using AWQ technique. So AWQ is an acronym for Activation Aware Quantization, and we're going to talk about that why this is one of the most critical techniques when we want to quantize a large language models. Now, quantization is itself a very complex, I'll say a problem or a domain, to work with because it kind of requires expertise of different types of data structures and algorithms. But we're gonna see how we can use AWQ to quantize Llama 3 in this video. Now, quantization of LLMs are important because not everybody has a GPU machine. For example, if you want to inference a model having 12 billion floating points or FP16 parameters, it's very difficult. You need GPU compute, you need sufficient VRAM to do so, and that's why we quantize LLMs. You would have heard about different types of quantization methods or techniques or frameworks, like bits and bytes, NF4, GPTQ, blah blah blah. Now, those quantization techniques have flaws in them, and AWQ is a bit different. We're going to talk about that and quantize Llama 3 and also inference. So we're going to create this video in different parts. So first we will quantize, then again we will push that on Hugging Face, load the quantized model and inference it and see a bit of evals on perplexity and things like that. So let's jump into the video and see how we can quantize LLMs like Llama 3. Now, if you look at here on my screen, I have the research paper that's called Activation Aware Weight Quantization for On-Device LLM Compression and Acceleration. They also have a different paper. I think I went into a different paper altogether. Okay. Oh, yeah, this is the one. Okay. Yeah, this is the paper that you should read it. Okay, it was proposed. You can see MIT Hand Lab. And if you want to understand a bit more, I will explain that on a very high level. I'll not go too deep into it, but I will talk that why AWK is important, and we're going to do this in Google Colab. You can see I'm using L4 GPU to quantize the LLM because again I have to load the model. So I'm going to use L4 GPU. You need Google Colab Pro to do so. Now, the most state of the art, as I said, the most state of the art LLMs are too large, right? We cannot load them, and that's where we come up with the quantization technique. We had people who have supported this in this quantization journey. We had Tom Jobbins, the bloke on Hugging Face who used to do it. Now he has stopped doing it for whatever reasons. We have Now's Research, Together Computer, and a lot of different individuals and researchers who helps us with quantizing large language models. And uh, and that's important because as I said, right, we are the people who have CPU machines. How can we inference these LLMs or build LLM powered applications? And that's why one of the way to reduce the size is quantization. Okay, now this is an active area of research, guys. There, and I believe there will be better quantization techniques in near future as well. The most popular is bits and bytes NF4. NF4 itself is a data structure. How do you look at quantization? I'm not going into too technical. I have created a video of fine tuning LLM crash course. Watch that video. But they don't focus. They do not focus on specific parameters. They when you talk about GPTQ and bits and bytes NF4, they treat all the parameters in the same way on the same level, but I don't think that is probably the best way of doing it. When you see, and because you lose a lot of information in that process, quantization, of course there is some performance degradation, there is no doubt about it, but when you look at bits and bytes NF4 and GPTQ, when you use these techniques to quantize, there are chances that you might lose a lot of information in the process. Okay, because they look at all parameters in the same way. Now, activation aware quantization are the technique that basically have been proposed for these kind of flaws. How we can solve this, which kind of protects important weights, and also it provides some importance, when to the parameters, and that's how it exploits a different algorithm, how to reorder. That's called reorder free online dequantization for faster inference as well. Now we're going to do that and we'll see how we're going to quantize this in Google Colab. You can see I've already have installed this, so I'm not going to install it again. And after that, what I'm going to do is I'm going to load Llama 3. So let's load Llama 3 over here. And we're going to do this in 4-bit. You can quantize a language model or an AI model in different bits. I just created a video. If you watch my previous videos, I've explained about memory consumption or requirement. Those are the fundamentals you guys should have it before watching this kind of complex video. Now, what we're going to do is let's get from AWQ import, and I want to import auto AWQ for causal. And you can see I have imported it successfully. I also need trans auto tokenizer, and let's get auto tokenizer. Okay, so let me just get that in. Yeah, so the next thing is we're gonna let me just add few cells, and here I want to have my model path. So my model path is we are going to take the model. Let me just open my Hugging Face. We are going to use Meta Llama 3 8B Hugging Face. Let's go on Hugging Face. Let's just get the repository name from here. Let's just copy it, and you can just paste. So our model path is done. Now we're going to have a quantization path. We're going to save this. So quant path, and quant path should be Llama 3. Okay, let's do it like this. Llama 3 8B and 8B AWQ, and I'm going to have, for example, 4-bit. This is my quant path. So you are okay with the quant path. Now I'm going to have a quant config. So you have to define a quantization configuration. So let me just define yes. So config, and in quant config, it's so you can pass key value pair. I'm going to have, you have to go through the research paper, guys, to understand different 0 point true. I'm going to have something called Q group size, and this becomes 128, and use fast equals true, and this looks good. Use fast, no, not use fast. So Q group size 0 point Q group size and weight bit. Okay, so we're gonna, the parameter is W underscore bit, and this is going to be 4. Now this looks good. Okay, so we are good with quant config. Let me just run this. Now we're gonna load the model and tokenizer. So let me just write it out here. Load the model and tokenizer. Quickly load the model and tokenizer, and I'm gonna do model equals, yeah, auto AWQ for causal LM dot from pre-trained, and I'm not going to give quantization config here. So let me just remove that model path, tokenizer, and model part, and then here I'm going to use fast true. It's a param, yes. It says you are trying to access, oh, excuse me, I have to logged in. So I'm going to do is from Hugging Face underscore hub import. Let's use notebook login here quickly. Notebook underscore login, and then I'm going to add a new cell, and I'm going to do notebook underscore login. Once you do that, you will be, let me get this access tokens here. Okay, to settings, go to access tokens, and just take, I will take the right one because I'm going to write that as well. So let me just get the right, you need a right privilege for that. Once you run this, you will be prompted to put, and once you click on login, it will log you for you, and then you again run this. This looks good. Let's just run it now. And it's going to take a bit of time, but I'm going to keep writing the code, guys. So the next thing is, once we load the model, you have to quantize. So let's use model.quantize, model.quantize, and inside model.quantize, I'm going to pass tokenizer. tokenizer, model dot tokenizer, and then quant config. Yes, quant config, and then you can also write quant config equals quant config because that's the param that it. Yes. And yeah, then you have to save the quantize. So let's save the quantized thingy here. Save the quantized model. And I'm gonna do model dot save quantize, not pre-train guys. Okay, model dot save underscore quantize. It should have yes, model dot save quantized and not quant path. Okay, so let me expand this now. Okay, and I will just make it like this. And then here I'm gonna write dot slash and plus quant path. So let's just write quant underscore path and then safe tensor. Okay, so we're gonna save this in safe tensor. Safe tensors equals true. Okay, and that's how we're gonna do that. What's my quant path? My quant path is yeah, that is fine. And then you just write it. This looks good. And we can also save the tokenizer. Okay, so tokenizer dot save pre-trained. Whew, and this looks good. Are we this is fine. Now let's just click on this. This process will take a few minutes, guys. Let's see how much time it takes. Now you can see it has started. I will come back once this is done, guys. All right, as you guys can see, the model has been quantized, and it took around 28 minutes. It was a bit slow. Most of the time when I have done it, it took 20 minutes as an average, but it took 28 minutes to quantize Llama 3 models, using AWQ. And you can see we have saved it over here. Llama 3 8B AWQ 4-bit. You can find it out over here. It has safe tensor, so you are safe with that. The model safe tensor. Otherwise, what happens? It creates a optimizer.pt or the model.pt, whatever, and then you have to convert that or at least use the adapter to merge if you are using different techniques. But here we already have passed safe tensors true to get the safe tensors one. Now if you look at here, we just have everything that we need here: config, special tokens, blah blah blah. Okay, now what I'm also do, let me just come over here, and you can see we have something called llama 3 8b awq 4-bit. When you come to files and version, it's still uploading. I'll probably will see that in a bit. We're also uploading it. Now how are we uploading it? I have shown that in my previous videos also, guys. There are multiple ways to upload a model or a checkpoint to Hugging Face. You can do it through Hugging Face API. You can even do through SFT trainer class. You can do it through different other techniques. You can manually also push it, but I'm just doing it here. Okay, now it's these are all big files. They are in GBs. It will take a lot of time to push that, but I'm pushing it on repository, and once that is done, I'll come back. As you can see, guys, the model has been pushed successfully. So we have pushed the quantized model successfully through Hugging Face API or HF API. And you can find it out here on my Hugging Face repository. You can see SQMA 307, Llama 3 8B AWQ 4-bit. So we have pushed the model, the quantized model over here, model of safe tensors, and we have all the config tokenizer files, whatever we needed over here. If you go to model card is empty, we can create a readme file to update this, but I keep on pushing models. We don't have time to create readmes and stuff, but you feel free to do that. And you can see it's fe16. When you use awq, when you are inferencing it, you have to load the model in fe16 torch float 16. You always have to do that. Keep this in mind. When you are using awq, you have to keep fe16 while inference. Now that will be faster as well. uh, Now what we will do, we will try to baseline without quantization. With quantization, how much time it takes, or memory, GPU compute and stuff like that, right? So uh, let's let's inference the model that we have pushed and see how it works. Now let's load the quantized model, guys, that we have, pushed. So I'm going to do transformers, and I'm going to do from transformers import auto tokenizer. So let's get that. And then auto model for causal LM. And then I'm going to do model auto. But keep one thing in mind, guys. You need Ampere architecture. If you want to use the quantized LLMs, if you have used AWQ to quantize something, you need Ampere architecture to run those. If you don't have L4 or A100 or H100 or the recent RTX, you will not be able to inference it. V100 and T4 are too old of GPUs, so it does not support that. Now, what I'm going to do now here is I'm going to change this quant path. I'm going to copy this one and paste. Okay, schema. And here I'm going to do few things. So d type torch d type. So let's just do torch underscore d type, and my torch d type are nothing but torch dot float 16. So let's keep float 16, and then device underscore map, and my device underscore map are nothing but whew, and let me see what should I get this. Let me open my gist, guys. I have a gist here. Okay, so I need a few things. What do I need? Okay, so I need a function that will help me get GPU thingy. Okay, so let me just get this. Okay, I have to install these again. Okay, because I've started the runtime due to GPU RAM and memory. So let me just do that. And yeah, it will take a bit of time. So let's keep writing the code meanwhile. So what we're gonna do next is add a few cells here, and then you know uh yeah, torch time. This is required. Let's get that. Torch comes pre-installed with collab. We do not have to do that. What else I need? I don't think I need anything else. I need this GPU utilization function that I have on my GitHub gist. Okay, so it says print GPU utilization. I'm using NVM init and handle. So I'm importing all the modules, so that is fine. And GPU, blah blah blah. This should do. Okay, what else we have? So I'm not going to perplexity and stuff. Okay, eval. Hmm. Okay. I think we are good with this, guys. Okay, so let's come back. Just a try. You can probably try it out. It's taking time to install. Yeah, yeah, yeah. Restart. I'll restart. Ah, when did I do, ah, when did I do, I don't know, when did I do, this is strange. I didn't do a keyboard. It says no module pi and VML. Okay, let's install then. Why it's saying like that? Okay. Requirement already satisfied. If I have to restart the runtime, I will do that. Let it happen. Okay, guys, we'll see. I'm not in any kind of rush here. Okay, this looks good. Oh, oh. Compute D type. We should also keep, well, see that. Okay. Now let me just restart a session. Okay, I'm starting the session. I don't have issue restarting the session. And okay, you should say, okay, I've installed from transformers, import auto tokenizer. That is fine. That is fine. That is fine. We need again the notebook login because we have restarted the sessions. I've deleted the runtime as well, so I need the token again. Okay. Let's come back. Run this thingy again, put my key here, and let's come down. I think we'll be good now. Okay, let's try it out. Yeah, this is fine. Import torch. This is fine. Okay. And what do we have to do here? So this is looking good. Uh, device map. We have device map. Tokenizer, tokenizer, tokenizer. Okay, but why do we need tokenizer? Okay, model. I just want to load the model and see how fast it is, guys. Okay, you should the benefit of speed as well. So we're gonna use the GPU function here. So print. I'm gonna use print GPU. What's my function name, by the way? Okay, uh, print GPU utilization, and that's a function. So let's print that function. And I'm not gonna go into eval. Let's try it out, guys. What happens? Yeah, you can see it's loading the model. At least we're gonna load the model and see how much time it takes. I just want to see the time. It should take and how much GPU, basically time and how much GPU it the memory occupies, right? When you are loading the model in when you load the started models. Okay, so and meanwhile I'll also write the next piece of code, which is I'll just copy I'll copy the entire thing, by the way. Okay, so let me just copy, come over here, and the only thing I'm gonna change is this one. Okay, so I'm not gonna use this. Okay, where is the meta thingy? Okay, so meta here. Okay, so let me just copy this, Control C, come back here, and for this I'll change the D type. Okay, oh, excuse me. Okay, oh, and after that we're gonna add a few things here. Let me see if I have it over here. Yes, I do have. So I'm gonna have these thing conditional here as well. It's BF16, this is fine. And I'm gonna say this compute D type then. Okay, so let me just do compute underscore D type, and device map and rest of the things looks nice. Okay, and yeah, and we are good guys now. Okay, so let's just wait for it. You can see one model has been, yeah, this is the second one will not take a lot of time. Okay, but the meta thingy will take a bit of time, so I have to probably pause the video, but let's try it out. Okay. These are all fascinating decoding and compression techniques, guys. Quantization is beautiful. I try to find some time. I'm a bit old school when it comes to learning, technology. I'm really old school. I do a lot of research, and I can see it says GPU memory occupied 6193 MB. Okay, so this is what it says. Now, I'm gonna use the same thingy over here for a Llama 38B by Meta AI. Let's try it out. Probably it will give me an error. Probably I don't know if it gives me a CUDA error. If it gives me, I'll restart, delete the runtime, and only load it for this, and then we'll compare that. Okay, let's see. Oh, true. It's gonna download a few things. I'll pause the video, come back once this is done. Oh, let's see. I think we'll keep talking. I don't want to pause the video because it's fast. Okay, so probably caching something because we have been loading it for a while, so it probably cache. But I'm just having a bit concern. I'm using L4, have around 50 GB of VRAM, so probably it will not give me a no space left on device. Let's try it out and see what happens. Okay, if that does, then we have to delete the runtime and start it again, and then only load this because we have the logs here. It says 6193 MB. You can see GPU memory occupied, which takes 6 GB of your VRAM. So if you work with quantization, okay, AWQ quantized model in 4-bit, it takes you 6 GB of VRAM. And now if you do it with this, it will probably take a lot. Let's try it out and see how much it takes. First, I have concern is if you will be able to load the model in memory. Okay, let's try it out and see. You can see now this is the main thing. This is the mother load. Okay, you can see loading checkpoint starts, and you can see GPU memory occupied 21701 MB. How much it is? Okay, it's almost 3.8x time, guys. It's more than 3x at least. So more than 3x of GPU memory occupied if you use the non-quantized. And you guys always ask me, hey, can you also show me the baseline? So you can also baseline it if you want to take a data set like Open Assistant, Guanaco, and you can then uh, perform the perplexity score and find it out over that as well. But I will leave up to you on that. Okay, you can try it out. I will give the notebook in description, guys, and this is what I wanted to do in this video. I wanted to show you how you can quantize an LLM with AWQ, because earlier I have shown how you can create a GGUF, with NF4 bits and bytes, blah blah blah. But how you can do that with AWQ is important, because AWQ, it basically helps you with giving preference on parameters, giving a special protection, and it's a different algorithm altogether. And that's why you should learn these as well. And let me know what you are doing with AWQ and with this video. If you quantize any model, and if you got any performance improvements or degradation, whatever, any kind of feedbacks, thoughts, let me know in the comment box. You can also reach out to me through my social media channels. Find those information on channel banner and channel about us. If you like the content I'm creating, please hit the like icon. And if you have not subscribed the channel yet, please do subscribe the channel, guys. That motivates me to create more such videos in near future. Share this video and 200 plus other Gen AI videos on my channel with your friends and to peer. Thank you so much for watching. See you in the next one.